On printing out the floating values, our output always returned very many digits, very many values after the decimal point. So if you had something like 8.5, we'd get like 8.50000. So under this, we want to set a decimal precision. Let's say I have a floating value like x being 7.8, and maybe I have a double value. Y, maybe it is 8.9. Let me terminate that. Let me make the floating value 7.8123. That way, maybe the double value 8.912. Okay, so we have a float value and a double value. On printing these values, if we just print f and then we print the value of x, we get 7.8123 and some other zeros after that. Same thing as y, we get more zeros at the end. So if you want to remove the extra zeros, we set the decimal precision. And how do we do this? We use a dot followed by the number that specifies how many digits that we need to have. So, for example, if I want to have only two decimal values being printed out for x, I will print, then I put percentage f. But then if I want to, I put the 2 behind, then I make it dot. So this is going to give me up to 2 floating values. Remember, x is 7.8123. So if I do that and I print out the value of x and terminate, let's build and run that. We're going to have 7.81. Okay. In other words, it has only printed up to 2 decimal digits. Other decimal digits have been eliminated. Okay. If we want to maybe print out if you want to print out for the double decimal values, this is the same. For the double decimal values, it's still the same. So we would have to use percentage dot to LF to have only 8.91. So you can see here, we have I have to change this one because it is a Y, it is a double value. If I build and run that, we have 8.91. I can also make them 4 so that I have an extra 0 on that. Let me make them 4 so that I will have 8.9120. So if I build and run that, we have 8.9120. So putting a dot and the value before the access specifier helps us to dictate the number of decimal points that we need within our printout. Thank you very much.